Hello students. Today I am going to discuss a very important problem in quantum mechanics. It says that E must be exceed the minimum value of Vx for every normalizable solution to the time independent Schrodinger equation. So if you want a physically acceptable or normalizable solution of time independent Schrodinger equation, and if a quantum particle is in a potential field, the energy of the particle should be greater than the minimum of the value of Vx. So what does this mean? So what this meaning? So suppose you have, say, I'm drawing a potential, say this is potential, and say this is the minimum of this potential. So this is the minimum, say this is my Vx, and this is the x, and this is the minimum of Vx. So if you want a normalizable solution, my E should be somewhere here. It cannot be less than Vx. That is the meaning of this statement. So for example, say let's say you have a Schrodinger equation equal to 2m upon h cut square Vx minus E psi. Now, if I say that Vx is always greater than E, my E is less than Vx always, then what will happen? This bracket will become positive. Now, the sign of d2 psi upon dx square depends only on sign psi. If psi positive, then your d2 psi upon dx square will be positive. If psi is negative, then your d2 psi upon dx square will be negative. What does implicate? So suppose if you have a, say, a psi which is positive, you have a psi x. If psi x is positive, then d2 psi is also positive. Now if I move, as I move x, if psi wants to come down, so it cannot come down. It will always move away from the axis. If it wants to come down towards the x, then because psi is positive, then d2 psi upon dx square should be positive. And now this is the slope of slope, and it is positive. So the psi only can go upwards. It cannot come down if it is a positive. If it starts somewhere positive, then it can go only move away from the x-axis upwards. Similarly, if it start with some value, say negative, then it can only go down because now d2 psi upon dx square is negative. Slope of slope is negative. So if psi wants to turn back, it cannot turn back. It always diverges as x goes away. So that means these kind of solutions are not normalizable, because in order to be normalized, psi should fall very quickly to zero as x approaches to infinity. So this is not a normalizable solution. If you want normalized solution, your E should be at least, okay, for normalizable solution, my E should be at least greater than equal to V minimum. So that's why, for example, when we are in a particle in a box, so here the boundaries you have V infinite, and here you have a V0. Now here particle should have a energy, total energy should be greater than V. That's why when you are dealing with a particle in box square wave potential, inside the potential always you have a total E is positive. E is greater than 0, because this is the V minimum, Vx, and it's a V minimum. My energy should be greater than this V minimum. That's why we always take E0 whenever we solve this problem. And classically also, if you see, my kinetic energy is given by total energy minus potential energy. If potential energy is uh, greater than this one always, then what will happen? We have a negative kinetic energy, which is also not acceptable. So, the this result we have to remember while solving the potential problems, that my E cannot be less than V minimum. E cannot be less than this V minimum whenever, if you want a physically acceptable normalized solution. Thank you very much.